Hello guys, welcome to my YouTube channel. My YouTube channel is Mwalimu Umar Saadi. You can subscribe that channel for you to get videos concerning chemistry classes. So in today's video, I want us to look at elements with exceptional electron configuration. In some of the previous videos, we have discussed how to write the electron arrangement of some elements, and we have seen that when writing the electron arrangement, we follow the Aufbau principle, which states that electron orbitals with lower energy is first filled before filling electron orbitals with higher energy. But there are some 10 diplock elements that do not follow this predicted pattern. So I have listed them here. We have chromium, copper, niobium, molybdenum, ruthenium, rhodium, palladium, silver, platinum, and gold. So these 10 diplock elements do not follow that predicted pattern. So let us see how to write the electron arrangement of some element here and where they have that exceptional. So let's start with chromium. And let's also see copper. So let us write the electron arrangement of copper and see where it has, chromium, and see where it has exceptionals. So first we will write our sublevels, 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d, 5f. So the first thing we will write the expected electron configuration. The expected electron configuration. So we will follow this pattern. So we'll have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Those are 20 electrons. Then 3d4, because we only have 24 electrons for chromium. So these are 20 electrons. So D can take up to now 4 electrons for chromium. So this now is the expected electron configuration of chromium. So let us draw or fill the electron orbitals of 4s2 and 3d4, the last two shells. So let's 4s2, and then we have 3d4. So D has 5 subshells. So we have 1, 2, 3, 4, 5. So let us fill 2 electrons there. And here we have 4 electrons. 1, 2, 3, 4. So those are 4 electrons in the D orbital. So in this way, D is not stable. So what will happen is that the 4s2 electron, 1 electron will move from S to the D orbital and occupies this empty sublevel. So now here we have now 3D that has 5 electrons and 4s that has 1 electron. So we'll have 4s, 1, and 3d that have 5 electrons. So in this way, the chromium electron configuration is stable because D has 5 electrons, it is half filled, and it is more stable than when it has 4 electrons. So the correct electron configuration will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d, no, not 4s2. 4s will only have 1 electron because 1 electron has moved from the 4s to the 3d, and 3d will have 3d, 5. So this is the correct way of writing the electron configuration of chromium. I think that one is clear. So let us go to the next one, that is copper. Copper has 29 electrons. So first we will write our sublevels: 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, then 4f, 5s, 5p, 5d, 5f. So chromium has 29 electrons. So let us write the expected electron configuration. The expected electron configuration. So let us follow our pattern here. So we'll have 1s2, 2s2, then 2p6, 3s2, then 3p6, then 4s2, and then 3d. 3d will have, these are 20 electrons, and chromium, copper has 29 electrons, so we are remaining with 9 electrons. So D can have 9 electrons there. So this is now the expected electron configuration of copper. So we'll again draw our last 2 shells. So here we have 4s2 and then 3d, 9, 3d, 9. D has 5 sub levels, 1, 2, 3, 4, 5, and then we have 4s. So let us fill that for 2 electrons. Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So those are 9 electrons in the D orbital. So what will happen now? In this way, D is not stable. So what will happen? 1 electron from S, 4s2 will move from here or jump from this 4s2 to the 3d orbital. So this electron will move to 3d and it goes there. So we'll remain now when 4s with 1 electron and a 3d that have 10 electrons. So the correct electron configuration of copper will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s, 4s1, because previously 4 has 2 electrons, but 1 electron has moved from 4s to the 3d, so we'll remain now with 4s1, and then 3d, 10, because it has accepted 1 electron from 4s to have 10 electrons. So in this way now, the d orbital is filled and it is more stable. So this is now the correct way of writing the electron configuration of copper. So if you have any question, you can ask through the comment. Any observations, any comment is highly recommended.